Introduction. Water-cooled chillers are essential temperature control systems used in large industrial and commercial applications. These systems are designed to remove unwanted heat from buildings, manufacturing processes, and equipment by using water as a heat transfer medium. Unlike air-cooled chillers that reject heat directly into the surrounding air, water-cooled chillers use a cooling tower to discharge heat. Because water is a better heat transfer medium than air, water-cooled chillers are generally more energy efficient in large-scale applications. They are widely used in large commercial HVAC systems, malls, hospitals, offices, manufacturing industries requiring precise temperature control, data centers where continuous cooling is critical, industrial process cooling systems. Water-cooled chillers are preferred where high cooling capacity, energy efficiency, and long-term operational stability are required. Working principle of a water-cooled chiller. A water-cooled chiller operates on the basic principle of the refrigeration cycle combined with heat exchange. The system removes heat from chilled water and transfers that heat to condenser water, which then carries it to the cooling tower for rejection into the atmosphere. Unlike air-cooled chillers, which use fans and ambient air for heat rejection, water-cooled chillers rely on condenser water circulation and cooling towers for better efficiency. Key stages of operation. Heat absorption at the evaporator. The evaporator is where cooling begins. Warm return water from the building enters the evaporator. Inside the evaporator, refrigerant absorbs heat from the water. As heat is absorbed, the refrigerant evaporates from liquid to gas. The water temperature drops and is then sent back to the building as chilled water. Compression process. The low-pressure refrigerant vapor leaves the evaporator and enters the compressor. The compressor increases the pressure and temperature of the refrigerant gas. This step is necessary to move refrigerant through the system and prepare it for heat rejection. Common compressor types used in water-cooled chillers: centrifugal compressor and large capacity systems, screw compressor, medium capacity, reciprocating compressor, smaller systems. Heat rejection at the condenser. The high-pressure hot refrigerant gas moves into the condenser. Here, condenser water coming from the cooling tower absorbs heat from the refrigerant. As the refrigerant loses heat, it condenses back into liquid form. The condenser water, now heated, flows to the cooling tower. Expansion valve process. The liquid refrigerant then passes through the expansion valve. The expansion valve reduces the pressure and temperature of the refrigerant before it enters the evaporator again. This completes the refrigeration cycle, and the process repeats continuously. Cooling tower operation. The heated condenser water travels to the cooling tower. In the cooling tower, heat is released into the atmosphere using evaporation and air movement. After cooling, the water returns to the condenser to continue the cycle. Water-cooled chiller versus air-cooled chiller. The main difference lies in the method of heat rejection. Air-cooled chiller uses fans to reject heat into air. Easier installation. Lower initial cost. Less efficient in high-capacity applications. Water-cooled chiller uses cooling tower for heat rejection. Higher efficiency in large buildings. Suitable for industrial and data center applications. Requires cooling tower and water treatment system. For large facilities focusing on energy efficiency and long-term cost savings, water-cooled chillers are generally more suitable. Key components. Summary. Evaporator. Absorbs heat from chilled water. Compressor. Increases refrigerant pressure. Condenser. Transfers heat to condenser water. Expansion valve. Regulates refrigerant flow. Cooling tower. Removes heat from condenser water. Understanding each component helps improve troubleshooting, efficiency, and system optimization.
Thank you for watching my video. I really appreciate you taking the time. See you next time.